Hello, everyone. So before going to detail into the today's topic, so I just wanted to introduce myself, a little brief about myself. So my name is Lokesh Chandra, and I have done MCA from MNIT Allahabad. And currently I am holding 4 years of experience in BookMyShow as an backend engineer. In that journey, I got a lot of opportunity to build and design very scalable services that can handle millions of the requests per minute. So that's it. That's all about myself. Now let's move on to today's topics. So topic is a Go memory management and garbage collector. So in that sessions, let's see about how Golang do our memory management and how garbage collector works and what is garbage collector, why memory management is required. So all these kind of questions and queries we will see in the sessions. Let's start with a code. So every developer writes code, right? We can simply write a code, start a main functions, and just calling a functions inside it. And during our program, we have also declared a lot of the variables and allocating some data as well, right? So here you can see already we haven't called any kind of databases functions, and we haven't stored any kind of values in databases. So where these values are holding the data, where our memory has allocated. So now that is the basically today topic. So we will see where these kind of variables are allocating data. So let's move on a simple example. I am just executing this example. So I will make sure, yeah, this program is holding some kind of data. So let's move into the code editor. Yeah, so you can, oh. Yeah, my screen is visible, right? For everyone? Oh, no. The code is basically same, whatever we saw in the PPT. So we are nothing doing here. We are just generating a data from a main function. So this is the main function, and from main function, we are calling a generate data. And generate data is basically creating a lot of the data. So I am just going to run this function, and before generating a large set of data, I am just printing memory stats. What is the memory status of a program before generating large set of data? And after generating large set of data, I will also see what is the memory status of a current program. Yeah, so you can see here the output. So before memory allocation, my program is holding 0 MB. And after memory allocations, my program is now holding 100 MB of data. 100 MB of data. So now the question arises where these data are basically allocated. So we will see in the detail. So let's move to the current slide. So now questions will arises in every developer's minds, everyone minds where is it allocated, how is it deallocated, and who handles allocations and deallocations. So we will see all these questions answers in coming slides, and we will go into the details. So here Go memory management come into the pictures. So the memory allocations and deallocations are happening in a program whenever we are declaring a variables, whenever we are calling a functions. So those kind of memory allocations and deallocations and its utilizations are all managed by the home memory management. Right? So this is the responsibility of home memory management. Let's move to the next slide. So now question has arises, do I have to manage it manually? I am writing a variable, I am declaring a variable, but now I have to allocate memory as well. Now I have to deallocate memory as well. No, I don't have to do it manually. It is automatically handled by the memory management. Whatever in the programming language, all have a memory management strategy. Now question is where it is allocated. So there is a two type of allocations are happening in entire program. So first is a stack memory allocation and second is a heap memory allocations. So we will see when we are declaring a variables, then how they are allocating inside the stack and which kind of variables will store inside the heap. So before was basically it was a yeah, so was a stack memory allocations and heap memory allocations. So now we will see this is the example that is an overview about the memory management when we write a program and writing a variables, declaring variables, calling a functions. So this is the overview. Some kind of our variables and some kind of our functions will be stored inside the stack, and some kind of variables and functions calls will be stored inside the heap. We will see in the details. Yeah, now question is when it is allocated inside the stack and when it will be allocated on the heap. So we will see in the detail what is the scenarios for this. So first is a stack memory allocations. So a stack is basically LIFO structure, last in first out. We already know about it. And the functions, in a functions, when we are declaring a local variables, when we are calling a functions from another functions, and when we are returning a control flow to the parent functions or some other functions. So that for that kind of returning functions reference or local variables are those kind of, in that scenarios, that memory will be allocated inside the stack. Let's see the example. So for the local variables, here inside a main functions, I am just declaring a n variables and assigning a 5 value and calling a square functions to return a square value of a number. So you can see here these stack frame for the main function are allocating inside the stack, or a square function for the stack frame is also allocated inside the stack. So variables and passing variables basically as a parameters are all the things are declaring inside the stack. So this is for the local variables. Now the next is basically not. Next is the function calls management. So when we are calling a functions from another functions, like here we are calling a square functions. So in that scenarios, we can see here for the square functions, these memory is also allocated inside the stack, and for the main functions itself is also allocated inside the stack. So for the functions call management, these kind of memories are also allocated inside the stack. But what about the memory deallocations? We have talked about the stack memory allocations in that scenario for the local variables, and for the functions calls are memory allocated inside the stack. But what about the memory deallocations? When they are happening, how basically it is managing. So let's see about the deallocations. So for the stack memory deallocations, when function return the values, when functions complete their instructions and they return the values, So in that scenarios, it will automatically popped out from the stack memory. So here we can see that we are calling a square function. When a square function complete their responsibility and it's returned value to the N2 variables. So in that scenarios, it will be automatically swiped up from the stack and it will be, memory will be clean from the stack. So it is automatically managed by the stack. Now let's move to the example. So we can see from example how memory is allocated inside the stack. So firstly, control we come at the main functions, and for the main functions itself. So for the main function itself will be declaring inside the stack first, and at the next instruction is basically n equal to 5. We are assigning a values inside the n variables. So those main functions and n variables both will be allocated inside the stack. Now next is key, we are calling a square functions to getting a square value of a numbers. So in that scenarios, a square functions itself is allocating inside the stack with their parameters value y equal to 5. And next key, when we are returning a square value to the main functions, and we are returning control as well to the main function. So in that scenario, when a square function complete their instructions, so now you can see here, stack frame for the square function are popped out from the stack and it will be cleaned basically. It has cleaned already. So now next slide is sorry, it's not working properly. 1 minute. So when all our program will be executed, when main function has completed itself and our entire program has run. So in that scenarios, all the memories that are basically allocated inside the stack, that will be cleaned up. And at the last point, our memory will be cleaned automatically. We don't need to manage it manually. So that was basically stack allocations. So till the points, you guys have any questions around the stack memory allocations? So you can ask. Yeah, for the recursive functions, so that was also a function calls, right? From a functions, we are calling a function regularly, right? In the loop. So in that scenario, that kind of memory also be allocated inside the stack. I am keeping a simple example. Yeah. Yes, today. Yeah. Okay, so now I am continuing to the heap memory allocations. Yeah, next is a heap memory allocation. So for that variables and the data structure that need to persist beyond the scope of functions calls, right? Firstly, we see basically when we are declaring a local variables, so that kind of memory allocated inside the stack, right? But we need some kind of variable that we want to access values from the different functions. For the many functions, we want those kind of variable accessible. So that is basically escaping their function scope. So in that scenarios, the memory for that variable will be allocated inside the heap. And when we are when we are creating a variables like make keyword, new keyword, or we are just returning a direct pointer to reference variable to that parent functions. So in that scenario as well, memory will be allocated inside the heap. Let's see the example. For the long life data, when we want to access a variable from another functions, for the create pointer, I am just declaring a values inside the X, and I am returning a pointer to the variables to the main functions. So in the from the main functions, we are printing value of X. So we in the main function, we are accessing the variable that are defined in the another functions. So for in that scenarios, we can see here for those variable, it will be allocated inside the heap. Yeah, for and another case is our dynamic data structure, like dynamic data structure like slice, map, and channels that require dynamic kind of data management. We can simply pass it on a dynamic data. So there, these kind of allocations are basically happening inside the heap. It's depend a different kind of scenario we will see about in the detail in the next slides. And for the large set of data, when we are defining a large set of data inside any kind of data structure. So in that scenario, so for those memory allocations are also will be allocated inside the heap. So here we can see example. I am just calling a large slice value and I am returning a large set of allocating large set of data. So these kind of memories also will be allocated inside the heap. Yeah, let's see about the our Go data structure stack versus heap allocations. For the Go data structure like array, slice, map, struct, and channels, we will see ki in what are the cases when we are declaring array or these data structures. So in that scenarios, the variable will be allocated inside the stack, and the memory will be allocated inside the heap. So first we will see about the array. So when for the small arrays, and when we are defining arrays data structure as a local variable and in a local scope. So for in that scenarios, the variables for memory of for these variables that will be allocated inside the stack. And for the array heap memory allocations, when we are just defined as a global array, and we want to access it from the all different kind of functions, so that definitely that will be allocated inside the heap. And for the large array definitions, whenever we have discussed in the we have saw in the previous slide, here we are just defining a very large set of data set. So there's these kind of memory also will be allocated inside the heap. Yeah. So next is struct. So struct is the same as array as well. So so for the local variables, same for the small struct. And if we want a short-lived object kind of data, so for the in that scenarios, it will be allocated inside the stack. And next is for the heap memory allocation for the struct, the same as an array. When we are creating a large set of a struct, and when we are returning a pointer reference to the parent functions, and when we are calling a some kind of creating a variable using new keyword that is returning a pointers reference. So in that scenarios also, the memory will be allocated inside the heap. Yeah. So now next data type is a slice. This is interesting. When we are declaring a slice, so in that for the slice, in that scenario, our memory is allocated inside the heap and stack both as well. Let's see, when we are declaring a slice with some kind of, here I am just taking an example and I am just defining a number of array inside a slice. So in that scenario, slice has some kind of meta header data, like called slice headers. Again, this is some conceptual representation. This is not exactly representation of the slice headers. I am just taking as an example. So the slice headers is holding a data that is a pointer and the length of slice and the capacity of slice. And whatever data is defined inside the slice, so that is a dynamic. We can change it as a program. We can increase it. That can be basically a large set of data as well. So for the underlying array, for the data, slice data, that data will be allocated inside the heap. And for the slice header, because the slice header is our basically limited, and it is a not growing kind of data. So for that slice header, it will be allocated inside the stack. Yeah, for the map as well, same as a slice, same as a slice. So basically, same as a slice, the map has a map header data, and underlying hash map is also there. So underlying hash map is also will be allocated inside the heap, and the header data will be allocated inside the stack. For the channel, so channel is basically dynamically in a nature. So when we are using a concurrent programming, when we are creating a lot of the go routines, so we are using a channels to communicate communication mediums for the go routines. So when we are creating a multiple threads, so channel is required to communicate between those kind of go routines variables. So in that, so channel is a dynamic in nature. So for that channels, memory will be allocated inside the heap. Yeah, so we will not only talk about the theories, we will do some practical as well. So let's see with an example how our variables are basically defining inside, allocating inside the heap, and which kind of variables are defining inside the stack. Let's see an example. Yeah. Not exactly. It's okay. Okay. Yeah, yeah. So please pass in the map.
Hello. So basically, primitive data types like string and int, those like all types of primitive data types in Golang would be stored in heap, stack, and non-primitive data types and complex data types would be stored in heap. Can we say that, or like there are
No, not we can say basically because when we are declaring a primitive kind of data like integer string, right? And if we are passing as a pointer reference, right? So they are scoping their functions, right? They are escaping their function scopes. So in that scenarios, for that those kind of variable as well, it will be allocated inside the heap, right? Because they need some kind of variables accessible from the different functions. It depends on the scenarios, right?
So if you're returning a pointer to an integer, if a function is doing that, then the compiler is smart enough to like allocate it on the heap. Yeah. So if a function returns a pointer to an integer, right? So that integer will be on the heap. So that will, once it goes out of scope, then it will be garbage. Then it will be collected.
So we will see in the dangling pointers in the next slides.
That's
coming slides. So let's move on to the example. It's feasible. So when we are running a program, so before running a program, go basically analyze entire program. So which kind of variable should be allocated inside the stack or a heap? So that process is that analysis called as a escape analysis. So we can use a command that is an escape analysis commands. So we can see key for these programs where memories are allocated. The command is basically GC flags. So we can use as a garbage collector as a flag, and the parameter is a -m. So -m basically representing if we are doing escape analysis, and we just want to print all the escape analysis things key, how basically and which kind of memory is allocated inside the stack and or heap. So we just run the program. So here we can see that the message, we will focus on the message. So the message is basically does not escape. So when we get some kind of message key, these variables or these kind of data does not escape. So so that means key it will not going to allocate inside the heap. It will be allocated inside the stack. And for the key a escape to the heap. So it means key for that kind of variables are going to allocate inside the heap. Here we can also see the message key escape to the heap. For these kind of variables are allocating inside the heap. So here we can using for you can use the command to see key where all kind of variables are allocating inside the heap or a stack. So let's see another example as well. So here you can see one more message, that is the move to the heap. Okay. So let's see what is the meaning of move to the heap. Let's see a program. So here in a get value functions, I am declaring a variable y and I am assigning a value stand, right? So it's behave like it is a local variables for the get value functions, like, but we are returning a pointer to the variables to the main functions. So now the y variables are escaping their function scope. So that is called key y should be allocated to the stack, but it will be now moved to the heap. So in that scenarios, we will get a message move to the heap. So in that scenario, y will be allocated inside the heap. Okay. Yeah. So now we have seen key the memory is allocated inside the heap or stack. So now if we see key, we want to analyze a code key where and which functions are holding that kind of memories at the very initial stage. We just saw in the command terminal key one of the generate data functions are holding 100 MB of data. Let's see this example. This is the generating data. So this generate data is holding our 100 MB of memory whenever we are just print that function. So we can see as a graphical representation as well using the pprof. So I am just taking a graphical representation to see which functions are storing and holding the memory data. So we are using the go test command and mem profile. So we can just analyze a program. Yeah, these generate data. We can analyze a program and just see which kind, how much data and how much memories are holding by the each functions. So here, this is our again. This is our print command printing. Basically, after memory allocation, that function is holding 100 MB. So let's see the here graphical representation. Is going to.
Bye. Bye. Chalo mi. Iti.
Okay, so when we have performed the go tool test command, so we have generated a mem.prof files. Now we will show the output of the mem.prof file. So just here we can see a graphical representation of our entire program. So this is our function, that is a generate data functions. So we can see here that our generate data functions is holding 102 MB, something approx 100 MB of data. So we can use the pprof to analyze our entire program, which kind of and which all the functions are holding how much memories. So we can use the pprof to analyze. Okay, so now back to the PPT. Till now, heap allocations and memory allocations, have you any doubt, any queries? Okay, so let's move to the next slide. So we talked about the heap memory allocations. Now we will say, what about the heap memory deallocations? And who is responsible for? How memory deallocations are happening for the heap? Okay. So now the garbage collector come into the picture. So garbage collector is responsible for the heap memory deallocations. We will see a overview about the garbage collector. So garbage collector is the background process that identify and reclaim memory that is no longer used in a program. So it will analyze in a background as a go routines. It will constantly analyze the entire program to identify where the unused memory are allocated inside the heap. So he just garbage collector just identify those kind of variables, and they are just starting process to swap it. And this also give a basically developer efficiency to just focus on their code, and they just developer don't need to manage it manually, allocations and deallocations. So importance of the garbage collector. So that is one point, is a prevention of memory leaks. So if garbage collector does not clean the unused memory inside the heap, so at some points app may have a lot of unused memory, and they can hold all of entire applications memories as well. So in that scenarios, memory leak will happen and application might crash. So that garbage collector prevent those kind of scenarios, and it provides the safety and reliability, and so those kind of dangling pointers. So before basically they are swiping memory from the heap, they make ensure if we are cleaning a memory for the variable A, so that memory is not pointed to the A. So they are completely reference has gone. So that they will ensure, and in that scenarios only they will clean that memories. So अगर ये ऐसा करके नहीं करेगा, right? So in that scenario, what will happen? A variable, it will be point to the B memories. So in that scenarios, dangling pointer of caches can happen. So it also prevent that dangling pointers, and it simplify concurrency management as well. So for in the Golangs, we are using a lot of the concurrent programs, and we are just creating a lot of the Go routines. So all the Go routines and concurrency scenarios, if developers has responsibility to manage the allocations and deallocations, so it might take a lot of a time, and it might some kind of bug will be still there, right? So we don't need to worry about those kind of things, and garbage collector manage it in the simplified way. Now the point is ki how garbage collector works, and it's clean the memory. We will see in their process, their working structures. So for the working garbage collector, there is only two phases. First, in the first phase, they will go through the entire program from the root level, and it basically mark all the references. And in the second phase, it will start the sweeping process. We will see in the that marking phase is called as a tricolor mark. Tricolor mark is consist of basically three color: white, gray, and black. We will see in the detail key what is the responsibility of each and every colors. So for the white object, so when go basically garbage collector initially start the marking phases. So at the very initial level, all the memories are initially marked as a white. And what is the white color, significance of the white color? So whenever memory has not reachable, and it can be reclaimed by the garbage collector in the sweeping phase. So for that kind of memory also mark as a white. For the gray, when garbage collector marking process in the progress, they are basically if they starting from the root and analyzing one by one variables, and they are just getting the all the reference for the particular variables. So they are still in the process. They might find some references, but it not finished. They are not explored all the references. The marking is in the process. So in that scenarios, the garbage collector for that memories, it will mark as a gray. When the marking phase has completed, and the gray, basically all the mark as gray, and when the marking phase has completed, then after that garbage collector knows now these memory is associated with that variables, and these variables is not referenced as any kind of with any kind of variables. So in that, so those memories is associated or has reference to the some kind of variables. So those memories and variables are marked as a black. And those memory has no any kind of reference, any kind of variables reference. So they are still marked, already marked as a white. It will be not going to the black. Now marking phase has a complete. The three color process, white, gray, and black. Now the sweeping process has started. In the sweeping processes, it will basically go through all the memories and see which memory has a mark as a white. And those memories as marked as a white, it will be just swept it from the memory. Because the memory, that kind of memories had no any reference to the any variables, right? Yeah, you can see here animations. I am just taking an example as animation. So from the root, garbage collector root, they are just starting analysis. And you can see here the edges as connected with the node. So those nodes are connected with the root. They are still marked, but these three nodes are not connected to the root. So they will mark as a white, and it will be swept. So this is the animated version of the understanding the garbage collector. Yeah, now let's see in a program, we have just shown at the very first level in the program, we have generated a 100 MB of data. My function is still holding a 100 MB of data. So now we will clean using a garbage collector. So I am taking same example. You can see here that generate function are generating the 100 MB of data. And from the main functions, we are basically printing the memory status and generating the data. And after that, we are also printing the memory status. Firstly, I'm running just a simple program. So run. Yeah, we can see here ki, before allocation that is 0 MB and after allocation 100 MB. So program is still holding a 100 MB. So now we will see the garbage collector is basically background process. It is automatically happening. We don't need to write it manually. But for the demo perspective, I am just manually triggering the garbage collector functions. So after generating the data, I am just here, I am just adding a start GC process. So start GC process will be trigger our garbage collector functions. And when our garbage collector functions will be executed, then basically I will just print that how much memories now our program is holding. Now you can see before memory allocation that is 0 MB, after memory allocation that is 100 MB, and after GC when our garbage collector run and it analyze the unused memory, because if our program will be executed, then those kind of variables we have not needed. So in that scenarios after garbage collector, that is again memory is going to swap and our program is holding 0 MB of data. Yeah, so that was basically all about the Go memory management and the garbage collector. So I have just finished. So do you have any questions? So you can ask. Yeah. Rastan, please pass the mic.
So in tricolor mark and sweep algorithm, you mentioned white, black, and gray.
Yeah.
You mentioned what will happen to white and black, but what will happen to the gray variables?
So gray is basically gray is key. That is key. Still we are marking in the marking phase. कि अगर मान लो कि मैंने अभी start किया, right? Start किया marking phase. So those in that की our Go routines are constantly finding कि कौन सा white color है, कौन सा white color है, right? And कौन सा gray color है and कौन सा black color है. In that scenarios. So in that scenarios की if some kind of variable is still not discovered, right? I'm just still searching about their references. So in that scenario, they will mark as a gray. And the gray, wherever we have just marked as a gray, जिसको हमने gray mark कर दिया, in the next phase, if we garbage collector just know कि yeah, we have find all the references for those memories. So the simply they will for those gray colors, इसको simply वो black color कर देगा. ग्रे कलर को कन्वर्ट करके वो ब्लैक कलर कर देगा क्योंकि मैंने उसका पूरा रेफरेंसेस उसका पूरा फाइंड कर लिया वैसा करके. एंड इफ वी नॉट गेट एनी काइंड ऑफ रेफरेंसेस फॉर दैट वेरिएबल्स वी विल जस्ट सिंपली मार्क एज अ व्हाइट.
So sweeping algorithm will never find a gray node. That's right.
Yes, sir. So CPU algorithm just find the white colors कि those variable and memory has marked as a white. We will simply clean them.
Okay, so how is tricolor mark and sweep algorithm different than a normal mark and sweep algorithm?
Okay. So basically this is I am not discovered. I am just basically discovered about the Go perspective. So I have to read about these things.
Another question is you mentioned we can't trigger garbage collection on its own. So how frequently is it triggered on its own?
So they have some kind of thresholds value, their internals basically. I haven't basically find what is their frequency and how basically they are running in the background. We have need to also research about what is their threshold value. So in that scenario, they are automatically triggering the garbage collectors.
Thank you.
Okay, thanks. Cool, cool. Thank you so much. Thank you so much. Yeah, thank you.